Hi guys, welcome back to my channel. So if you are new to my channel, my name is Arnabi Mitra and I am a power programmer at Infosys. So generally I make videos on how to prepare for coding exams and coding interviews. And this is my fourth video of this series where I am discussing the previous year power programmer assessment questions. So if you haven't watched the first three videos, I will suggest go and check those videos. There I also explain three more questions, and today I will be solving one of the medium question which was asked for the power programmer assessment. And before starting the video, I would like to share that I have one telegram group where I every day put a question for the members to solve. And I prepared this group basically so that who are preparing for the power programmer exam, it will be helpful for them. I have analyzed the previous year question, and based on that question, all the questions I every day put a coding questions from Leetcode so that people can solve and they can have a consistency. So if you are interested, you can join my telegram group and keep on practicing. So I will move to the questions. Okay, so the question saying we will be given one number n, and we need to find the number of combination of n length possible with all the numbers from 1 to n such that at ith position either I minus 1 or I plus 1 can be there. So we will be given one number n and we need to find prepare the like combination from 1 to n. All numbers will be there, and there is one restriction that at ith position either I minus 1 can be there, I can be there, or I plus 1 there. So suppose we have we need to put any value at the second position. We can put 1, 2 or 3. We can't put 4 or 5 like this. So let's check out some examples. So first example, when the value is 2. So we have value of n is 2. So we have 1 and 2, and we need to prepare combinations with 1 and 2. So there are two possible combinations, that is 1 2 and 2 1. So if you notice these combinations, basically 1 2 is the where ith element is at ith position, and in 2 1 at the first position 2 obviously can stay. At first position 1 plus 1 2 that can stay, and at the second position uh, 2 minus 1 1 can stay. So this is fine. These two are only valid positions and we can put them. Now let's take one example for 3. Okay, so when the value is 3, let's check the positions. 1 2 3, 2 1 3. Sorry, I have put in here 1 2 3. It will be 1 3 2. Yeah, so there are three valid positions. So 1 to 3 is obviously valid, this is fine. Now 2 1 3 is also fine because we didn't change any value. Because 2 1 is also valid, we can put 1 in the first position, 1 in the second position, 2 in the first position, and 3 can stay here. And 3 can also stay in the second position. 1 is in first position and 2 can stay in the third position. Now let's think of some more examples, and let's see, can we make any more combination with 1 2 3? For example, 3 at first, then 1, then 2. See, we can't prepare this one because we can't put 3 in the first position, because we can only put I at I minus 1, I or I plus position. So actual position of 3 is at last. So we can take it in the previous one, but we can't take it in I minus 2th position. So this is not an valid option. Now, with 3, at beginning we have 3 1 2 and 3 2 1. So these two are not valid because we can't put 3 here, so we are just not taking this. Now suppose we are putting 2 at front, now 3, now 1. This is also not valid position because maybe 2 at first position is fine, 3 at second position is fine, but 1 at third position is not fine. So this is also not a valid position. So we know with 3 we can make a total 6 combination, but I just show you that why 3 are not valid and only these 3 are only valid. So I will now move to the next example. When the value is 4. So 1 2 3 4 2 1 3 4 1 3 2 4 1 2 4 3 2 1 4 3. These are the valid one. So only this 5 are valid. We can't take any other valid. So I will ask you just put some pen and paper and try to have some combination and check if they are valid or not. For example, we can't put this 3 at front, so all the positions starting with 3 will be discarded. We can't take this 4 at front, so all with 4 at front will be discarded. We can't take 1 at the third position or the last position. So like this we can't take them. So only this 5 are the valid one. Now this is the time for thinking like how we will solve the question. So at the first glance you may think that this is an combination type of thing. We may try all the combination and then keep on checking one by one and we will keep on discarding. So you can do it, but let's check the time complexity what we should do. So as I always mention in all my videos, that you first check the constant, and based on that only we will go for our solution. So I have one video where I discuss how we should check the constant first and then decide the time complexity. So if you haven't watched it, I would suggest go and check that video first. Then you will understand like why we should first check the constant. So here it's saying the in value of n is 1 to 10 to the power 8. That means we need to go for one linear solution. We have no other option. So let's observe the patterns. So the one pattern, when you are coming to the example 4, you can see when the value of n is 4. So 4th will obviously the last element. So at the last element, at the last position, at nth position, we can put n minus 1 in or n plus 1. Now here no scope of putting n plus 1 because we have only 1 to n. So no chance of n plus 1. So, in which positions we can put 4? Either it can stay at last or it can stay at last in minus 1 position. So, if you observe this, we have placed 4 at last or at n minus 1. So, if you go for the example 3, we have put 3 at last or n minus 1 position. So, this is one example, an observation that will help us to solve. Now the next thing, okay, so we can put n at last or n minus 1. So when we are putting n minus 1 position, the last element at n minus 1 position, what are the elements we can put at last? So if you notice, when 4 is at third position, so at fourth position we can only put 3, we can't put 2. We can only put the second last element to the last position because we can't put 2. It will be n plus 2 for it. So if we go like this, so we have two options to put the 4, either at last position or at second last position. And when we are putting this 4 at second last position, we need to put 3 at the last position. So this 4 3 is fixed, and for first 3 combination this 4 is fixed. Now for last 2 combination this 4 3 is fixed. Now we need to think how we will populate the other values. Now see, when we are fixing the 4 at last position, so we can simply take the n minus 1 positions combination. See, this 1 2 3 2 1 3 1 3 2. See, I have only put the valid combination of the n minus 1 combination and just put in at last. So if we have the valid combination of n minus 1 position, we can take them and put n at last, and we will find sum of the nth position. Now when we are putting 4 and 3, we can simply take the valid combination of n minus 2, see 1 2 and 2 1, and we can put like them. So when we are going for n equals to 5, then what we will do, suppose n is 5, we will put 5 here, 5 here, 5 here, 5 here, 5 here. So this is valid when 5 at last. Now then we will go to n minus 1 position. We will take them. We will put them and put like 5 4 5 4 5 4. So it's nothing but we are just adding the value of n minus 1 plus n minus 2 with valid position. So when value is 5, it's 5 plus 3, that is 8. So this is if you know the trick, then it is very simple. So these are the observation. When we put the last number at there is two valid position for n. Either we can put it at nth position or n minus 1th position. So if we put n at last position, then we can take all the valid elements of the previous one and add n at last. And if we are putting n as second last position, we will take all the valid combination of n minus 1 and put them. Sorry, n minus 2 and put like n followed by n minus 1. This is n followed by n minus 1, like this. So the equation is simple. We will create one function as f of n minus 1 plus f of n minus 2, and for that we need the two base answers. So when value is 1, we have only one combination, that is 1 only, and when value function for 2 is 2, 1 2 and 2 1. So for this is a very simple code, so I'm not defining it. I guess you can do it. Now as we need to do it in linear time, so it's better we just do it using a for loop. We can take one variable that will keep on adding the previous two, and we will populate the second last and last as we move on. So it's like similar to finding the Fibonacci series using for loop. We won't be using recursion because we need to solve it in linear time. So I hope you understood the solution, and if you have any doubt, you can let me know in the comment section. And I would want to say that this solution is provided by Ankun Kumar Mitra. I will give his LinkedIn ID in the description. If you want to connect with him, you can connect. And if you like this video, please like, share and subscribe to my